Hello everyone, welcome to my channel Learning Electronics. In this video we are going to learn about some basic topics related to bipolar junction transistor, that is BJT. So before that, please subscribe my channel and also press the bell icon so that you can get more updated videos here. So let us see what is BJT. BJT stands for bipolar junction transistor. It is a solid state semiconductor device with three terminals, that is emitter, base and collector. It is called as bipolar junction transistor because the current conduction in this type of transistor is due to two types of charge carriers, that is electrons and holes. The bipolar junction transistor was developed by Dr. Shockley in 1951. It is widely used device in modern electronic circuits such as digital computers, satellites, mobile phones, control systems, communication systems, etc. As I told that it is a three-terminal device whose output current or voltage or power is controlled by input current. Since output parameter is controlled by input current, it is called as current control device. It is made up of silicon or germanium material. Its features are it has compact size, rugged construction, more resistive to shocks and vibrations, instantaneous operation, high efficiency, low operating voltage and long life. Next one is BJT construction. BJT, as you can see in this diagram, this is a schematic diagram of BJT or bipolar junction transistor. It has three regions: emitter region, base region and collector region. Based on the connection of the N-type and P-type material, it is divided into two types of transistors. One is NPN transistor and second one is PNP transistor. NPN transistor is formed when one P-type material is sandwiched between two N-type materials, and PNP transistor is formed when one N-type material is sandwiched between two P-type materials. As you can see in this diagram, this transistor has two junctions. The junction between emitter and base region is called as emitter base junction, and the junction between base region and collector region is called as collector base junction. Both NPN and PNP transistors has two junctions. As I told that it has three regions: emitter region, base region and collector region. So let us discuss about these regions briefly. First one is emitter region. Emitter region, as shown in the diagram, it is a left region of the transistor and its function is to supply majority charge carriers to the base region. Electrons are majority charge carrier in case of NPN transistor and holes are majority charge carriers in case of PNP transistor, and majority charge carriers are always supplied towards base. Emitter region is forward bias with respect to base. Why it is forward bias? To supply majority charge carriers to base region. Emitter region is heavily doped. Why it is heavily doped? So that it can inject majority charge carriers, large number of majority charge carriers into base region. Next one is base region. As you can see in the diagram, base region is between emitter region and collector region, and it is very lightly doped and very thin of the order of micrometer. It is thinner than emitter and collector region. Why it is very lightly doped? So that whenever the charge carriers come from emitter region towards base region, only small amount of charge carriers can recombine here, and rest of the charge carriers are collected by the collector. So it supplied most of the charge carriers to the collector. Therefore it is lightly doped region. Third one is collector region. It is the right region of the transistor and it's moderately doped. Moderately doped means the doping is between emitter region and base region. The collector's main function is to collect majority charge carriers coming from the emitter region through base region. Collector is always reversed bias to remove charge carriers away from the junction. Let us see the BJT symbols. As we have studied that there are two transistors. One is NPN and second one is PNP transistor. How we recognize the transistor is NPN or PNP? If it is a PNP transistor, then the arrowhead in the emitter region is towards the base region. Means the arrowhead is inwards always. If it is an NPN transistor, the arrowhead in the emitter region is always from base region to towards emitter region. Means the arrowhead is always outwards. This is the equivalent diagram in terms of PN junctions for the PNP and NPN transistor. If it is a PNP transistor, then the diode equivalent is two diodes connected in this fashion, and if it is an NPN transistor, the diode equivalent is two diodes connected in this fashion. Two PN junction diodes are connected here. Next one is terminal identification. It is the two types of packaging of the transistor. If we want to recognize the terminals, then in this type of packaging, the emitter is towards left side, base is in middle, and collector toward right side. If it is the packaging is like this, then base is in left side, emitter is right side, and collector is back side.
What is transistor? A transistor consists of two p-n junctions formed by sandwiching either p-type or n-type semiconductor between a pair of opposite types. There are two types of junction transistor. First one is NPN transistor and second one is PNP transistor. This portion is called emitter, this is called base, and this is called collector. This is circuit symbol for NPN transistor and this is for PNP transistor. देखो सर्किट सिंबल में आपको एक चीज ध्यान रखनी है, ये एरो की डायरेक्शन, ये एरो हमेशा शो करता है करंट की डायरेक्शन को और करंट फ्लो करता है हमेशा P टू N. अब NPN के केस में ये एरो इस डायरेक्शन की तरफ है. इट मींस करंट फ्लो कर रहा है P टू N. इट मींस ये पोर्शन P है, अगर ये P है तो ये भी N होगा और ये भी N होगा. इन केस ऑफ PNP ट्रांजिस्टर ये एरो इस डायरेक्शन में शो कर रहा है, मींस करंट फ्लो करता है P टू N, मींस ये P पोर्शन है, ये भी P है, तो ये वाला कौन सा हो जाएगा? N हो जाएगा. इफ यू वांट टू अंडरस्टैंड दिस टॉपिक इन मोर डिटेल, प्लीज क्लिक ऑन द लिंक गिवन इन द कमेंट सेक्शन. थैंक यू.